Okay, so I'm going to fill out this table for the quadrilaterals so that we can all get on the same page. And what I'm going to do is highlight each of the properties that's true so that you can see what's going on in each of these sketches. So you can see kind of the same idea is going on in each one of these boxes, but each quadrilateral has different features that are said to be true. So in a parallelogram, it's called a parallelogram because the opposite sides are both parallel. So we say both pairs of opposite sides are parallel and both pairs of opposite sides are congruent. All right, guys, I'm making this highlighter smaller because it just totally highlighted too much for me. So let me do a better job at that. Both pairs of sides are parallel and both pairs are congruent. So that's the first thing about this opposite sides. In a parallelogram, opposite angles, both pairs of angles are congruent. And in a parallelogram, the diagonals bisect one another. So let's add into this picture what we can. So both pairs of opposite sides are congruent. So this side is congruent to this one. This is congruent to this one. This opposite angle is congruent to this one. And then these opposite angles are also congruent. And what we're saying about the diagonals is that if we redraw this thing and we draw in two diagonals to it, they would bisect each other. So I'll do 3 markings on this one and 4 on that one. So they would bisect one another when they intersect in the center. All right, rectangle. Way more familiar are the rectangle and the square, which is going to be on the next page. So the rectangle, we're going to start with the fact that a rectangle, this is a parallelogram. Oh my goodness, I cannot write to fit in this space. This is a parallelogram. That's what I'm going to write. That's my abbreviation for it, okay? So it has all the same features of a parallelogram and then some. So we know that both pairs of opposite sides are parallel and both pairs of opposite sides are congruent. We know even further that all angles in a rectangle are congruent. And because all of the angles in the rectangle are congruent, we also know that its diagonals are congruent and they bisect one another. So let's add all of this into the picture. We know that these opposite sides are congruent. We know that every angle is a 90-degree angle, and that means all the angles are congruent. And then we also know that when we draw in the diagonals, not only are they congruent, but when they bisect each other, they create 4 equal segments inside that because they are 2 congruent diagonals that bisect one another. So there's a lot that's special inside of the rectangle. Let's keep moving. In the rhombus, I also want to state that a rhombus is a parallelogram. Well, okay, it is a parallelogram. So it also has the features of a parallelogram, but it has a few additional features as well. So in a rhombus, we do still have both pairs of opposite sides are parallel. But I'm hoping what you can actually tell additionally about the sides is that all of the sides are congruent. So if we keep moving, we can see that in the rhombus, we have both pairs of opposite angles congruent. You can tell from this picture that the opposite angles are not all congruent, or so that not all the angles are congruent. There are 2 obtuse angles and 2 acute angles. So because this is a parallelogram, we know that the diagonals bisect each other. But in a rhombus, there's one equally special thing. They are also perpendicular to one another. So let's look at how we could define this. In a rhombus, all of the sides are congruent. So every side would have the same marking. And the opposite angles are congruent. So these angles are congruent, and these two opposite angles are congruent. But specifically when I redraw this to draw in the diagonals, I want to make sure, I'm not doing a great job, but when I draw in the diagonals, I want to make sure everyone can tell that not only do they bisect one another, but they form a 90-degree angle in the center of this picture. Okay, they are perpendicular to one another. Okay, I'm going to move to the next page, page 28 in your packet, to allow me to continue with the quadrilaterals. Okay, so we're on page 28. The next one is a square. Sorry, the font on this side is a little bit smaller, but I needed to make sure I fit the whole page. Okay, so what we're looking for now are the features of a square. Now, I want to be crystal clear. A square is a rhombus with equal angles. So a square has every property of a rhombus with the exceptional property that all of its angles are congruent, because we do know that every angle in a square is a 90-degree angle. That's something that we all know by definition. Okay, so let's go back to the sides. So we know that because a square is a rhombus and because a rhombus is a parallelogram, that both pairs of opposite sides will be parallel. And we also know by definition that all sides of a square are congruent. This is also true because a square is a rhombus. What we need to figure out is what's going on with those diagonals. So remember, this is a rhombus. So we know the diagonals must be perpendicular and they must bisect one another. But there's one additional special feature, and it's that the diagonals are also congruent to one another. So I'm going to take, this image is going to go off the page just because I want to fit it here. So that's my square. And I'm going to draw in my diagonals. So they do intersect at a 90-degree angle, but more importantly, they were already congruent to one another. So when we bisect them, it forms 4 equal pieces of the diagonals here that we can see. 4 equal chunks. Okay, let's keep moving. All right. So when we go to the next one, we have a kite. Okay, so in our kite, this is a little bit different because there is no particular relationship between the sides. There are no parallel sides in a kite. However, I'm going to add a statement that the adjacent sides are congruent. And I'm going to go to the picture before I highlight that statement that I just wrote, because I want to make sure you understand what I mean. Adjacent means the sides that are side by side. So adjacent means they share a vertex. So we have these sides that are congruent. So let's go ahead and highlight that. We know that that's going to be true. And I mean like a kite, like the ones you used to fly as a little kid. Like that is what I'm referring to. So in terms of the angles in a kite, there's only one pair of opposite angles that are congruent. And in terms of its diagonals, they are perpendicular. I want you to think of how you would make a kite as a child. It was always starting with a cross, and then you would lay the fabric on top. But in this case, only one bisects the other. So let's talk about the angles first. The congruent angles are these two. These two angles are congruent. Okay, the two obtuse angles on the opposite ends of the kite, or on the opposite corners. All right, but what about the diagonals? I'm going to redraw this guy so that you guys can see the diagonals. I'm going to draw the longer diagonal, and then I'm going to draw the shorter one. So now this shorter diagonal is bisected by the longer one, but most importantly, they also form that 90-degree angle inside of the kite itself. All right, guys, trapezoids have very few features that are required. The only requirement to be a trapezoid is that we have one pair of parallel sides. So I'm going to use markers on the sides. These markers mean that these sides are parallel to one another. That does not mean that they are congruent. It just means that they're parallel. The other sides can be the same. They can be different. There's no requirement for the other two sides. Unless we're talking about an isosceles trapezoid, because that is different. It's still a trapezoid, so we have one pair of parallel sides, but because it's isosceles, we also have one pair of congruent sides. So these two sides that are horizontal, they are parallel, but the shorter legs are congruent. So what we actually have when we look at this figure is a new angle relationship. Now we know that the adjacent angles are congruent. And so I'm going to go ahead and highlight these. What does that mean? Adjacent means they're sitting like next to one another. So that means these two base angles are congruent, and these non-base angles up top are congruent. And finally, we also see that in an isosceles trapezoid, the diagonals are congruent and they bisect each other. So let me draw. This is not going to do very well because I can't draw anything isosceles by hand. Oops, I already messed it up. All right, we're trying my best.